words of Martin Luther King, I hope you judge me by the quality of my character and not the quality of my slides. Well, you know, abridged. Yeah, it's appropriate to throw a talk together about escape rooms, as escape rooms are also thrown together hastily, and I can't even do the buckle on my waistcoat. That's how incompetent I am. So, hello everyone. Hi. I'm really glad to be here. Partly because you guys actually all turn up to meetups when you arrange to have them. We've forgotten how to do that in Brighton. Literally everyone cancels last minute and then no one comes. I've had friends who've actually sent me a photo. I've sent a message, oh, I'm sorry I haven't made it. And they sent me a photo of an empty room and some biscuits. And it's really, and that kind of heartbreaking. So, yeah. Right, my name's Paul Hayes. I used to be a games developer, and now I've decided to go strictly into making escape rooms. If you want to know how I made the leap, I'll explain that at the end or something. But basically, making games in places where it's more permanent, like museums, escape rooms. That's it. That's the process. I guess I'm doing this talk as a kind of post-mortem where I'm just kind of airing my thoughts. As such, it might be a bit all over the place. And also because I've literally come from another game of running a game there for my brother who's visiting from Australia. So it's all been a bit crazy. And I have loved doing this, but I'm going to be running backwards and forwards, aren't I? Firstly, yeah, escape rooms are home automation. Changed my mind. So that's I kind of had that epiphany where I spent a while now building Internet of Things stuff at home and just tinkering in at home and trying to make stuff like self-watering units and stuff. And I've always taken kind of a decentralized approach. I've come from a network kind of a background. I've always been fascinated by the internet since I was like 13. So I've always been decentralizing things. And I was asked to do a puzzle last year for an escape room, and they had an entire decentralized network structure for their escape room, and it was awful. It cost them an absolute fortune to do. I was given very bad documentation for how to integrate a microcontroller, and microcontrollers aren't really the best things still to put on networks. It's way out of their depth, so you immediately have to bulk on. Anyway, I'm getting ahead of myself. The point is, I've always done network and decentralized stuff. And actually, you know what? Home automation, you don't need to go crazy and network and decentralized. We have all these amazing pre-existing technologies. So I've just finished this. It's the first escape room I've done everything that is electronic, and I built the whole communication system from the ground up. I'm very proud of it. It's below a cafe called Nowhere Man. It's run and designed by Peer Pressure, this is their 5th escape room. Admittedly, one of them they've just closed down, so they've got 4 operational at the moment. And it's a recreation of the lanes, as you can see, which is ambitious. And the principle, the storyline is you're there to steal a diamond before a nefarious gang steal the same diamond. So it's a heist movie in microcosm. So there was a lot of challenges to this. The challenge with escape rooms is, although they make money, they don't have crazy high budgets. So if you're doing an escape room, you do not have the development time of computer games. You do not have development times of museum projects. In fact, I've built something for a museum that I had 3 months to build it. I had 3 months to build the entire escape room. And that was, even then, was slightly less than 3 months. I just had a look at my calendar because there were some delays. So it was terrifying doing everything this quickly. However, if you want to build stuff cheaply, the most expensive thing is my time, I've realized, compared to amazing technology you can buy off the shelf. And if I was to try and build that, it would take me months. If I could buy it off the shelf and it's £100, that's great. That's nothing. in comparison. So trying to rely on buying things off the shelf, which isn't something I do at home. I try to do it myself because I'm stingy, and actually I realize my own time is more valuable. So that's taught me a few things. Now, first I just want to mention about my tools. I don't know how much, so I don't know what everyone's backgrounds are, so I'm literally just going to say what I use and hope some of this sticks. So I used to use the Arduino IDE for microcontroller stuff. I no longer use that. I use Visual Studio Code and Platformio. If you ask me why, it's because it integrates really well with Git. It has code auto-completion. It has really good library support. So if I have my own Git repository, I can actually use that as a library, and it will download that repo and install it as a library automatically. So if literally I can make my own packages, whereas if you want to publish something to using the Arduino IDE so that you can bring in a third-party package that you've made, you actually have to properly publish it. Whereas this, you can do like private repos as well and all that. It's just a really, Visual Studio Code, obviously you can use it to do Python, JavaScript, C, C++, any language really, because it's extensible. So that's a nice combo rather than the Arduino IDE, which is actually looking really old and tired and really should probably be retired. Okay, so Git. Sorry, just a show of hands. How many people here are software developers? Okay, that's quite a lot of you. And how many of you use Git? Yeah, exactly. So that's almost 100% of software developers have got used to version control with Git. I came from SVN, and I've given talks on Git because it's fucking amazing. But the problem is, I'm sure it's the same for almost everyone. You've got a problem with Git, you Google it, and there's a bunch of obscure commands you'd even know existed, and then you type them and it fixes it, and it's great. That being said, actually, the philosophy behind how Git version control works is amazing. It's taught me a lot. So Node and Node-RED. Obviously, probably everyone's heard of Node, the kind of command line, server-side JavaScript engine. Who's heard of Node-RED? Can I just see a show of hands? Oh, only two. Okay. Three. Okay. Do we have more than three? No. Good. That was kind of my breakthrough thing for doing an escape room, because we didn't have money to develop software for doing the logic of the escape room. And my final thing is OpenSCAD. Has anyone heard of OpenSCAD? Yeah, it's fucking weird. So if you're a programmer and you like writing code, you might not be the kind of person who likes using a keyboard and mouse for doing design. So as soon as I got a mouse in my hand, I feel like I'm out of my depth. So if I have measurements and I want to design a model, OpenSCAD lets me write it as code. So it's an entirely like algorithmic version of a modeling program. So it's really great. I'll give you a little demo of that later. It's quite old in itself now, but they actually are still working on it. There are some people who forked other versions and things like that, who are doing other things with it. There's an ecosystem, but OpenSCAD is 95% of people doing kind of like writing pure code to generate 3D models. So okay, moving on. So Node-RED. This is Node-RED, and it was like it was made for escape rooms, and I think that's got a lot to do with, once again, that automation principle. So if you know the website If This Then That, that's a good example of just trying to create a flow. When something happens, take some data, do some things to it, and then send it to something else. It's a kind of input, do some stuff, output kind of program. Here's an example of the general layout and some things. And you've got over here, these are inputs, and then some code happens. Each one of these has got some JavaScript in it. This is entirely running in Node, and then it actually lets you access it via your browser. It creates a web server, and you kind of do all your GUI stuff on a local server. So it can be run obviously in the cloud. You rent servers to run it, or you can run them locally. And it's pretty lightweight, even though it's written in JavaScript. It will run fine on a Raspberry Pi. So once again, really good for home automation. You want a Raspberry Pi. you don't want to spend a lot of time coding, or if you code, you don't necessarily want to SSH into your box and start writing loads of code. You have to do everything from the ground up. This instantly lets you create connections between things. So, for instance, you can see here there's a list of inputs. Yes, you could just send a UDP message or a TCP message over a network or WebSockets. You can actually do so. For instance, if there's you want to if you want to send an email, or you've got an API you want to connect for online, you can just drop these in, take these inputs, and then connect them through to some output. It also has, so this is the general design of coding. It's a just simple graphic UI. It takes a little bit of getting used to, but oh my God, it's so simple, and it kind of teaches you to make your code nice and readable. I think if anyone's ever tried visual coding and felt a little dissatisfied, I certainly have. This has been a really good visual coding experience. And for people who've not really done much coding as well, because as a coder, sometimes if I've got a visual coding system and it only lets me do it visually, I can't write some traditional code, I feel hamstrung. It's like someone's just tied my shoelaces together. Each one of these little things, I can just double click on it. Why don't I should actually just open the thing and give you a demo. But you imagine I can open one of these up and there's just some JavaScript. And I can just type some JavaScript. But also there are nodes for doing things like branching. So you can essentially write if statements actually through the graphic UI as well. So it's up to you, whichever one you feel more comfortable with. Not only that, for free, you get a second UI called the dashboard. And this was perfect. This is when I saw it had a dashboard system, I was like, oh my God, there's literally a month's worth of work that I don't have to do, because I needed to create a UI for the people who operate the escape room. So has anyone who's here has been to an escape room? Okay, so not very many people. Escape rooms are amazing. All go to an escape room. Doesn't matter. It doesn't have to be one of mine. Just go to an escape room. They're really fun. It's a great activity to do with friends you're close with, or people you would like to get to know better. It's a great way of employees like chilling out after work and feeling like you actually kind of get to know each other a bit better. It's just fab. Like the escape rooms are just, you've got 1 hour to run through all of the puzzles in a room to escape. And those puzzles are normally waterfalled, so that you have to solve some that give you things to solve the others. And so the entire thing is interconnected. It's an interconnected series of puzzles. And they normally have a theme. They normally quite, cinematic or narrative driven. So there's normally a reason you're given for trying to break out of a room. So they can be a bit like being inside of a movie. As I said, like Loot the Lanes, it's a heist movie. There's one I'm going to in Berlin in a few weeks where it's actually like Indiana Jones or The Goonies, where you're going through like these caverns and there's like skulls and you've got to put the skulls in certain places. And I've been told it's the best escape room in Europe. So I'm really looking forward to that. So, but behind the scenes, there's a person watching the players, and their job is essentially to help to make sure the players don't get stuck. It's essentially they are the tutorial system, they are the hint system, a whole bunch of stuff that you might in a computer game rely on software. You're outsourcing to one person who's monitoring them. They're the person that sends you into the room, that gives you the story, and behind the scenes they've got CCTV cameras and they're monitoring you constantly, and they can give you clues and hints, and they can make sure that you don't get stuck. And if anything breaks, and they can tell you not to break stuff, because people break stuff in escape rooms, and they're like, please don't pull that doesn't move. So there's all these things that the operator has to do, which means that some of the things are, they've already got a lot on their plate. So in terms of automation, the job is, if it's cheap to automate, we automate it. If it's expensive to automate, the operator does it manually. So this is a really simple template. Basically, it's got 2 puzzles. This force unlock button on each one of them is in case it breaks or something goes wrong, and you're like, oh, well, they did it right, so I'm going to unlock it for them, and then whatever unlocks. And often there's a lot of, I'll get into the ins and outs of that. I've kind of done the slide in the wrong order there. I'm going to change that. But most importantly is you've got frick of an hour to solve this. So when you go in the room, they hit start, and that starts the countdown. Okay, now moving on. So that is a self-generating UI that Node-RED actually makes for you. If I skip back a slide, you'll see there's a node here, button. If you drag in a button node, a button will appear on that UI, and you can basically configure it to say what you want and do something when that button is pressed. So it's fab. It's absolutely perfect for escape rooms, and I think it's pretty much perfect for any home automation scenario where you want a manual trigger or you want to monitor how things are going. For instance, say you've got temperature sensors or humidity sensors. You can feed that data into Node-RED, and then there's a graph plotting UI element, and you just drag in a graph plotting UI element, and it will graph it for you. And straight away, you've taken some sensory information and you've displayed it somewhere, which is great. Okay, so escape rooms. Escape rooms are home automation. If you look at any kind of home automation diagram, you'll see pretty much the same diagram. You've got a bunch of sensors, and you've got a bunch of outputs, and you've got some logic. And if you're very lucky, you have a UI which is for monitoring or adjusting settings and things like that. You might even have some manual things which trigger some outputs based on user intervention, like the force unlock button in the escape room. So these are the kind of things you might expect to see in an escape room. You've got some switches, keypads, environmental sensors, card readers. Yeah, that basically stuff that people interact with. Some traditional button-y things like arcade buttons, but some things are a little bit weirder. And I'll show you what I mean. And on the output side, just the same. You'd expect some lights and some locks. Locks feature heavily in an escape room, as you might imagine. You're trying to escape, and information has to be hidden, things have to be hidden, and players have to move through the experience. And so locks form a big part of that. Now, there's also some weird components. Things you might not imagine turn up in an escape room. Barcode scanners, MIDI instruments, smoke machines, lasers, and most recently I've actually put a bastardized version of a CNC machine. I can't really tell you what it does, but it does something quite complicated in an escape room. But it was like, I need an off-the-shelf, multi-axis, accurate system for moving. CNC machines are really cheap and they're modular, and so I just bought all the parts for a CNC machine that was a bit big, and it doesn't CNC, it doesn't cut or anything like that. It's quite safe. It doesn't have a spindle or anything like that, but essentially it thinks it's a CNC machine. So that's a really weird one. And all of these, and the previous slide, connect to Node-RED without any problems. And that was my real surprise. I wasn't expecting to get quite so much for free. Oh God, what's that? That's not me. Huh, I've lost the slide. I'm sorry, I actually had badges earlier as well. Now I felt bad. All right, I'm gonna delete the images which are, oh no, that's so orcs. Okay, my God, that was the most boring slide now. There was like four GIFs there. It was really cool. Oh. Okay, well, you guys will live, right? I might show some pictures at the end, just so you don't miss out on this, because there's some fun things. Oh, I feel really bad. That's so annoying. Okay, so. Right, outputs. So, yeah, so these are the kind of, oh God. I've lost my train of thought now because of the previous one. So obviously I've been mentioning Arduinos a lot. You might think, okay, Paul, but Arduino is meant to make devices that do stuff, and any microcontroller. When I say Arduinos here, really do think I'm talking about cheap, easily programmable microcontrollers, not just Arduinos, not just Arduino compatibles. There are ones by Texas Instruments, and similar boards. That's why another reason to use Platformio. Platformio has support for basically it's kind of microcontroller agnostic. You can install all these amazing other libraries for other systems, I think some of the systems I just haven't got the grips with. There's like the Intel Tesla thing, and there's oh God, what are the Texas Instruments ones called? Launchpad. Was that what you're going to say? No. There's a kind of Arduino kind of clone called Launchpad. Adafruit and SparkFun make a bunch of boards like the Feathers. And most of them are programmable in the Platformio IDE. The point of them is you write some code, you put that code on them, and then they easily do input and output. Now, some of the things I'm having to interface with are servo motors, relays, and addressable LED lights. So I can think of a dozen uses. I think a classic one is locks, right? So this is the most common thing, and it's quite a home automation thing as well, because you might be like, I want it so that I can unlock the front door. Okay, if someone rings my doorbell, and I look at the webcam, and I get sent a photo of them. That is a perfect, and then I remotely unlock the door. That's a perfect thing to do in Node-RED. It's just absolutely perfect for it. Almost everything you need is straight out of the box. So I would install Node-RED on a computer. Now, I didn't use a Raspberry Pi for this. I actually bought an old refurbished like HP desktop PC for like £160. It's like an Intel 2-core processor, like a couple of gigs of RAM, more than enough for my needs. And for £160, and significantly more useful than a Raspberry Pi out of the box, just about the right price point. Obviously, takes up a lot more space, but that's about the only really significant drawback to it. I installed Node-RED on that. Now you might be thinking like, this is all well and good, but I want to see those examples. I've made a template. You can see it online. I will have links at the end. Basically, I'm creating a universal escape room template for other people to use, and I hope that if you're interested in Node-RED, it's a good starting point for like, here we go, how to interface with things that are external devices. So you would say take a webcam, you would take some type of locking mechanism. There are 3 main types, maglocks. Oh God, I've forgotten the word. Not latch. Oh, that is so annoying. No, it is the name of the thing that sits in the door frame. Nope. Oh God. Now I'm making you play it like it's a game. Okay. Oh, come on. Nope, that is not coming up. Okay, forget it. If you've ever been buzzed into a building and it's not been a maglock, it'll be this kind where it has a handle to operate it on one side, it has a push plate on the other. There is no electronics on the door itself. Instead, there is a small catch that's solenoid operated on the inside of the door. The name escapes you at the moment. That's the other type of lock. Maglocks are just big magnetic plates that are electromagnets. So when you close the metal plate, and so that they're normally useful in places where if the power is shut down, you want people to be able to escape, like fire escapes, things like that. The third type are called cabinet locks, and they're a bit weird, and I've used them significantly in escape rooms where you've got little cabinets that pop open out of nowhere. Because they're sprung loaded, they kick the door open. And one of the things you find with locks in escape rooms is you'll unlock something 10 meters away unlocks, no one notices. And then everyone's like, what, did something happen? And no one, you need it to like, I've just unlocked something, click, and it's a really satisfying clink, and the door little opens a bit. And they're really great. Cabinet locks are super perfect for escape rooms, unless you keep them on all the time, in which case, if you accidentally power it on, they're only meant to be on for about 3 seconds. If you leave them on for more than 3 seconds, they really start to heat up, which is slightly terrifying. And I'm like, I don't know if that would pass certain safety regulations, but so far, and as it's controlled by software, It is slightly terrifying. I've not had them do anything too dangerous, but I have had them so hot that you can't really touch it. So I guess that is one downside. So for instance, going back to our example of our home automation front door remote opening system, then you might find yourself, someone rings the doorbell, you need that button press to obviously make the normal doorbell ringing sound, and you also need it to go and send you a message live. So you can send a message on, say, the WhatsApp, or, I mean, if you wanted to, Twitter, theoretically, but more likely an SMS. And you can use an SMS service to send yourself a text. And you can even include the image of the person who's ringing the doorbell. And that's really easily done in Node-RED. And then you send them some kind of release back. So you need to send a message back. You could either do that via SMS, or you could actually have a proxy back to your house and have the dashboard that I pointed out earlier, and you could add a button to the dashboard to manually unlock. You can all kind of blend that together. If you want a keypad that also unlocks the door, you could also introduce a keypad. It's extremely easy to get switches with, switches. It's very to get keys that are actually switches. So you can, instead of a normal switch, as a normal key in your house that unlocks a latch, you have the key send a message to your computer, and your computer then opens the latch. Which I know sounds extreme, but if you're going to also remote open, then it solves the problem of how to have both the manual and the, kind of physical manual and the electronic version of the opening operate the same thing. The trick is to essentially have the key fake it. So moving on, that's outputs.
Thank you.
Right, okay. Okay, I'm just going to connect now. By the way, this is my life in tabs. I don't know if anyone else suffers from this, but I'm kind of fine with that. It's like that group of tabs on the far left, there's 7 tabs, that's roughly high level organization, timekeeping, stuff like that. Kind of middle is kind of current research going on, and the stuff on the right now is this kind of, it's a stack.
How do you make the tabs so small?
Exactly. You just have that many tabs. It just goes that small when you push it that hard, and there's no excuse for it. This is my life in tabs. It's kind of terrifying. I have an apprentice, like an assistant, and he's always horrified by my tabs. Like he has to look away. Okay, I think that should be all right now. Now I feel bad about deleting the ones earlier. Well, we're going to do a slideshow, so it'll be fun. It'll be one of those slideshows where I'll ask you not to look at the ones that I don't highlight, because some of them probably will upset my client if they get shared. Actually, yeah, don't. Oh, and we got video as well. But these are fine. These are fine. It's the ones where it's actually some of the it's probably spoilers at least. Okay, so if you're opening a lock, you need to sometimes they're 12 volts, sometimes they're mains controlled. I was originally going to do that all with Arduinos, and then I found these things, and it was like, oh my god, that is a real cash saver and a time saver. I wouldn't say they're the nicest things in the world to work with. They are a bit cheap, but they are cheap. So it's both the positive and negative. So I don't know if you guys know your electronics very well, but anyone who's ever done any electronic stuff will recognize the ubiquitous relay. It's electromechanical. Basically, a small voltage turns on a coil of wire which pulls via electromagnetic force, pulls a switch over and makes contact with another panel, and that connects these things together. So, oh god, that was that was probably the worst description of a relay ever. So essentially what we are doing is this very low voltage circuit, because USB is 5 volts, is powering an electromagnet, which then flicks this switch and enables you to actually turn mains power on and off. And you can run anything through this you want. One is the common connector, and one is a normally closed and a normally open. And the reason why you have a normally closed and normally open is you might want it so that it's always on unless you turn the relay on. Or you might want it so that it's not on unless you turn the relay on. So a good example of that is the mag lock. You want it to lock when it's not powered. So when this is off, you want the lock to be on, and then when you turn the relay on, you want it to unlock. So you connect up the normally closed parts up. So the normally closed and common you connect together, and that will open your thing. Now these are identical in the like kind of operational usage, but they're completely different in the way they communicate, even though they're both USB. I got these ones first, and I thought they were great until I realized the horrible thing. If you have a bunch, I have 5 or 6 of these in the escape room. I was going to have 5 or 6 of these in the escape room. There's no way for you to differentiate them. They have no serial number. So if you plug them on a different USB port, they'll have a different COM port number on the computer. And there is no way of identifying the difference between them. So if you unplug a USB port and plug it into a different USB port, it will have a different COM number, and your code will no longer be able to find it and will not be able to differentiate them. So, that's horrible. These ones are amazing because they are using a microcontroller that I regularly use, the AT-Tiny85. It's an Atmel microcontroller. I love these things. They're great. They cost 20p, and I can program them with Arduino. I can program them with Platformio. So a 20p microcontroller with onboard flash. It's got almost everything I could need on 8 pins. They are brilliant, and they are a kind of software solution to problems which would normally only require hardware. So yes, these guys communicate via something called HID. HID is the same system that USB uses to do mice, keyboards, joysticks. They're human interface devices. So obviously this is not a human interface device, and it completely breaks specification. And the story behind them involves an Austrian company who are like, let's make it so that anyone can make USB HID devices. Oh no, we've made it so that anyone can create USB HID devices. Oh dear God, what are they making? These things are not human interface devices, but pretend they are to the computer. There are some lovely Node libraries that enable me to turn these on and off. And so I wrote another library, references at the end of the talk, that enabled me to turn these relays on and off, which is a lot better than these because these have a serial number. And so I can actually tell them apart, which was like fabulous. If you want to use these with Node-RED, I've got a library that enables you to use them in Node-RED, and I'll give a little demonstration of that in a bit. Oh my God. Oh God. I don't know if this is too much. It's a ridiculously overly complicated diagram. I bet you all feel like you're in a kind of first year university course with a diagram like this. This monster is actually a really simple diagram. They're the most simple things in the world. Each one of these is just a sensor that you can connect to an Arduino. So some sensors you might be able to get away with directly connecting to a computer if they're USB, but I'm talking about like just a component you might buy off eBay. A good example is the cheapest of all of these components, maybe, it's a tough choice between these two. A momentary button, for instance, an arcade button, or just a micro switch. They are momentary, so as soon as you press down, it changes its state, and you release it, it will go back to the original state. So you might say, why have you written stateless? And the reason is because really when you're using them, you don't hold them down, you just press them on and off. These guys up here, if you're connecting these to an Arduino, generally, as soon as they do something, you just want to tell the computer. And I'll get onto how in a bit. But these ones down here, when you get information from them, they always have some form of state. So let me give an example of that. Potentiometer. So a potentiometer is a dial, or if you've ever seen a fade mixer on a mixing desk, or any kind of, all those dials on mixing desks you get. Those are potentiometers. So their job is basically to output an analog value. They're extremely easy to wire up on the Arduino because it's 3 pins. One you connect to ground, one you connect to voltage, and one is your one is the is the analog information you're trying to read, and you run that into an analog pin on the Arduino, and you simply ask the Arduino what's the analog value, and it will give you a number between between 0 and 1024, or 1023 actually, and you could then send that information back to Node-RED, right? So it's very easy to just pass on that information. But you only want to send it when it changes. So these guys are a bit weird. You've got a potentiometer, it changes its value. You can read that value anytime. In fact, you should probably be reading that value constantly, but only send a message back to the computer when that value changes. Because otherwise you're just going to be bombarding the PC with just the same value over and over again. Whereas these guys, they are essentially interrupt. You're saying like, oh, you've pressed a key on a keypad, or oh, we've received an infrared pulse. Oh, a rotary encoder. By the way, God, what are rotary encoders? Rotary encoders are normally optical devices which strap to motors so you can tell when the motor is moving and how fast. That's what they're for. But you can use them not with a motor. You can just set them on a dial and they don't have limits. You can just keep turning them. They don't know where their position is in absolute terms, unlike a potentiometer, which has limits, right? You turn a potentiometer, you get to one end or the other. Rotary encoders are limitless. You just keep turning them all day and they'll keep sending pulses. But that means they don't really know where they are. They just know whether they've moved left or right. And that's a rotary encoder. They are, I don't know if you've ever had a hi-fi system that has them, but some modern hi-fis, they don't actually have limits. You can keep turning the volume knob all day long, and they'll normally reset to a value. That's basically doing lots of stuff in software. Rotary encoders are more common now for stuff where it's controlled by a computer, because the computer can reset the state. The computer can be like, oh, I want to take the volume down to 0. It can't turn the dial. Actually, God, do you know that? Remember those 90s amps where they would actually like physically turn the dial for you? They're amazing, but no, nowadays it's like, oh, no, I'm going to, in software, turn the volume down, and I'll just reset where my position is. That's what rotary encoders are, and they're fab, but they don't know where they are. They don't have an absolute position. So as such, there is a very different way you handle these and these from each other. I'm going to put up as many examples of these kind of inputs, because when we're communicating, the idea is to send them onto the computer, not to try to do the processing on the Arduino. The whole goal of doing the escape rooms is to keep the price low. Arduinos are very cheap, but writing lots of code on the microcontroller and having to debug that, and having to come in and change a value if the client says, oh, I'm sorry, can you modify it? That's a real pain. With Node-RED, I can actually just connect via TeamView and I can make changes in my copy and commit it to the GitHub repo, and they can pull the changes. So I don't need to re-push any information to the microcontroller. So I tried to keep the microcontrollers as dumb as possible. Their job is essentially to be the fingers and, to be like the sensory skin or the actuating muscles of a finger, but the brains are all in the center PC. So yes, I've gone completely centralized, and my whole philosophy has changed on doing escape rooms, is to go way more centralized. Okay, we are approaching the end of the talk. So, communication, getting these microcontrollers and Arduinos to communicate to Node-RED. And also other things to communicate with Node-RED. Yeah, that's right. It's The Arrival. Great film. If you haven't seen it, watch The Arrival. It's like hard sci-fi. It's quite fun. It can be very daunting sending and receiving messages to an Arduino over serial. Not so much on the sending back to the computer. That's fairly easy because you have a command called serial.print, and it will just send text straight back to the computer, no questions asked. Receiving messages from the computer is a little bit more complicated, and as such, I've written a library, links at the end of the talk. Right. However, imagine if you didn't need to do any Arduino coding at all. What if I was to tell you, oh my God, great news, guys. If you're not an Arduino programmer and you don't really want to learn C and you're not interested in that at all, you don't have to worry. Fermata exists. Fermata is a piece of firmware that will compile and upload to almost any Arduino compatible microcontroller board. So it's a kind of one size fits all. It will then report all information straight back to the PC. So it basically becomes like a complete dumb terminal. It doesn't even need to be told how to communicate. That's all built into the firmware. Wouldn't it be nice if Node-RED had a built-in package to communicate with Fermata? It does. Great. Okay, so you can drop in a node, and I'll give you a quick demo of this now. You can drop in a node. Oh God, there we go. Okay, so here's Node-RED running on my laptop, but pretend it's running on another computer, and I've just connected to it over a network. And down here, we have an input and an output. So inputs, if you wanted to read a button, a button is a digital input pin, and you would put the pin number. Let's put input pin 2. We'd select the Arduino board. We don't actually currently have an Arduino board because I forgot to bring one, but pretend I did. And now, any time that a button is connected and pressed down on pin 2 on that Arduino, it will send a message out of this with the value, whether it's high or low, indicating whether the button is down or up. So basically, every time it is either up or down, it will send a message, a pulse will come out of this. And you can then do some processing. So I'll give you a little example. I'm going to drop in a little JavaScript node to do some thinking. And then if we wanted to, say, unlock a door, doesn't have to be on the same Arduino. It could be on another Arduino somewhere else. It could be, if this was a plant watering system, we might have a tiny little Arduino, like one of the Nanos or something like that. That could have a moisture sensor, and there could be another Arduino with a pump connected somewhere else on a long tube that will actually push water somewhere. So these could be completely different Arduinos, and I mean, if we wanted it clever, we might want on, for instance, a pump to turn on for a certain amount of time. There is a delay node. So what we would do is normally have, we'd have a thing that said turn pump on. So there'd be some code in here to construct the message that would, I mean, for instance, it might be really simple. We might just want to turn the pump on. We might just do message dot payload equals true. So we're just going to send it true. And this pin, so to turn on the pump, it's pin 10. Now, I'd say a digital pump would be most likely. You can get these motor shields for Arduinos. A lot of the peripherals that plug into Arduinos come is either as pre-made shields, which is a slot on top, for the Uno platform or the Mega platform. They're quite large ones. I don't tend to use them as much, but for beginners, they're absolutely fabulous. They enable you to quickly add features which would normally require an entire knowledge of electronics. Like if you want to add a DC motor, i.e. a motor which just turns depending on how much voltage it's receiving, you can just get a DC motor shield and just put it on top of the Arduino, and boom, you're done. So I'm just going to imagine that. And then we might only want to turn it on for a little bit of time. So you'd send a message to turn it on, and then send another one to turn it off. And we might want to turn the motor on for 5 seconds. So we would probably go from here and run that there and connect those guys up. So let me reorganize that because I think visually it makes a little bit more sense. Cool, there we go. So basically, yes, immediately turn on the motor, wait 5 seconds, and then turn the motor off. And that's how you would do it. It's that simple. So all of that control is now entirely on the computer. The Arduinos have just got Fermata firmware on them, and you're done. And like for me, that can save like the escape room loads of money and means that I'm doing actual difficult code, not really obvious, you know, really simple code that doesn't really, it's not value for money for the escape room, turning things on and off with, but yeah. So you might have noticed that almost everything I've done so far is using USB. And if you're, I mean, does anyone know the biggest problem with USB? Yeah, obviously other than it exists in a quantum state where you need, that there's 3 different orientations for a 2-sided object. Yeah, it's got, no, that's not, anyone else have a guess what the big problem of doing home automation with USB is? Yes, exactly. USB doesn't want to run very far. It was never built to run over long distances. Yeah, and that was the major, I think that's the most reason most people don't do USBs in escape rooms. And I kind of took a different approach because firstly I have a friend who's a Spark and he does really interesting installations in houses and stuff. And we were chatting and he mentioned that you can buy a box that runs USB over Cat5. There we go. So that's the basic one. I actually much prefer the 4-port, but here's the basic one. These are expensive boxes if you're thinking, this is by far the most expensive bit of kit. That's like £90. So that does seem a bit pricey, but when you're building an escape room, that's only a few hours of my time. And suddenly we can run USB 60 meters. They make a 4-port version, so it gives you 4 ports on the output, and it doesn't need any power on the output. It takes 24 volts on the input side, which is great if you're making an escape room, by the way, because plug sockets are at a premium. Those things are everywhere. Like you can't really use plug sockets because if people can unplug what you've made, the escape room fails. So you need to hide everything that you've made. And so plug sockets are a real premium. They're all hidden behind cabinets and things. So the idea of being able to run power and have 4 things plugged in on USB, and it costs £100, that's great. And you're running it over CAT, as in Ethernet. So it looks like it's an Ethernet cable because it's using the cable you use for Ethernet, but it's not. It's just repurposing it. So that's a bit weird in itself. So you pick it up and you think, oh, this is a network cable. But you take just an ordinary network cable like this. Sorry. And instead of using it for Ethernet, it's actually using it to send USB signals from one end, and it can do it over 60 meters with no problems, and it's transmitting 24 volts of power. So it's a wonder because now escape rooms can actually be fairly large. I know the name seems to imply that they take place in a single room, but normally they are multiple rooms. Spoilers. So yeah, you've got this weird scenario where if you run Ethernet across the entire escape room, it can actually be 60 meters in places because it's got to go round all the corners of the room. I think some of ours were running 40 meters. So yeah, this is a kind of expensive piece of kit, but as you can see, it's hard wearing, it's metal case, it's got screw fittings, and for an escape room, that's really great because everything has to be screwed down and hidden away and be electrically safe. So these are an absolute godsend.
How about a USB bridge? I've got one at home that works off Wi-Fi and then just comes out with USB port and it presents itself as a USB port on your PC.
So Wi-Fi in general is a bit of a no-no in escape rooms, right? Because it's a nightmare to test if it goes wrong. Everything's hidden away, you see. So like if you've got, and we've got loads of interference. We've got so much EMF going on. We've got like electromagnets everywhere. I ran an audio cable across from one area to another, and I listened to it, and it's like the sounds of an electronic city. It's like got so many different octaves and baud rates. It's like an orchestra of electromagnetic like radiation. So yeah, no, nightmare. Wi-Fi just does not work.
Well, they work on Ethernet as well.
Yeah, that's an interesting one. I've been thinking about trying one of the Ethernet ones where it actually is using a network. But there's still the question there of point to point. Remember, I've got to run lots of them. So I've got to know which ones pair up with which other ones. So at least with
serial number, so it comes up with whatever serial number on your, looks like a local USB port on your PC.
Okay, so it would be fine on
So you can plug any
on a
USB
hub.
device on it you want. You could even plug a USB hub on the end of it.
Yeah, okay, that's pretty good. I definitely would consider one of those next time. Essentially, they essentially do the same thing, but I could run them through a hub, which is an advantage. I could run them through a network hub rather than a USB hub.
And I think we take power over Ethernet. Not 100% sure on that. So
Yeah, well, similar to this, they're running
they're
power from the input side.
powered USB ports.
Yeah, same as these. So yeah, they fit the criteria. They're a definite alternative, doing such a similar job. One advantage I can see of them is being able to have a lot more than 4 ports running over a single Ethernet cable, because you can create an actual switch. You can put switches in at different locations.
Yeah, it works on Ethernet.
So
Ethernet.
you can actually put switches in. You can't connect those to switches. Right. So where were we? Find the talk. Find the talk tab quickly. Okay. Just wanted to mention a few other. What's the word? Honorary mentions. So you mentioned I had a CNC earlier. That's just serial messages to. I don't know if you guys know much about 3D printers or CNCs. They all essentially work on the same protocol called G-code, which is serial messages sent over a USB connection, and they're really simple. It's all text-based. So 3D printers send text commands to. Your 3D printing program essentially is a bunch of text commands. And if you've got a 3D printer that has that is receiving G-code via an SD card, it's just loaded. That G-code is literally just a series of text instructions of what to do, where to move, how hot to run, things like that. It's a pretty good system, and I actually found it worked really well with Node-RED. So I was actually able to send CNC instructions from Node-RED, and it was able to move motors to particular locations, which was a real godsend. That's a lot of code I didn't have to write. If you're dealing with stepper motors, very accurate motors that can get to particular locations, it can be really problematic. Calibrating that, making sure it doesn't move too fast or too slow, and all of that's pretty much handled by the CNC. Okay, last 3. These guys, you can run variants all over USB. DMX is for lighting systems. I've used it for like museum lighting and stuff like that, where you've got like an installation and lights need to turn on a particular pattern. You can control that from Node-RED. MIDI, bizarrely, both input and output, you can control with Node-RED. So you might be thinking, like, isn't MIDI for music? Well, if you take a MIDI controller, it's just a bunch of buttons. If you take a keyboard, it's just a bunch of buttons. And those buttons you might want to take and do something else with. And when you're making escape rooms, oh my God, are you doing weird things with buttons? So I had great success using MIDI in the escape room. You can run MIDI over USB, and most USB MIDI devices, most MIDI devices these days are USB. You can get converter cables that will take a MIDI and go to USB. So these, an OSC, is it OSC? Yes. It was kind of built as an alternate, as a kind of next generation MIDI by an open source community, and has kind of to some degree been taken up, but it's still a bit fringy. It was open source controller, not sure. So basically, Node-RED can do all of this. It's able to communicate on all these levels, like directly talk to Arduinos and turn pins on and off and read inputs from pins, talk serial messages to things, both Arduinos and CNC machines and all these other crazy things. HID, other HID controllers. Now that's the one area we don't really have, other than my relay module, notes at the end of the talk. Other than that, for turning on HID relays, unfortunately other HID devices, not so much, which is a shame. I'd like to be able to use joysticks and be able to plug those in and be able to use them in Node-RED, but currently that's not available. So we'll see. Time will tell. If I have some more time, I might make a library. Same with DMX for lighting. Oh, DMX, by the way, if you've got a smoke machine and you want to control it from Node-RED, yeah, you can get a DMX smoke machine, plug it into USB, drop in a Node-RED DMX node, and turn a smoke machine on and off. Literally writing no code, which is fabulous. But not only that, you can buy a DMX flamethrower for large-scale events. So, like, if you've ever been at an event and you've seen like timed flames coming up, I think they had some at Eurovision one year. It was like, yeah, you can buy those, and they're just DMX. You just plug them in, and you've got yourself a computer-controlled flamethrower. So, yeah, you're welcome. Okay, we are at the end of the talk, and just go to GitHub, Paul Hayes, and you will find all of my random makings. But these are the notable ones. I've made an escape room template if you want to make an escape room, or home automation if you want to automatically water your plants, make yourself a cup of tea, open your front door when someone knocks, or just about anything you can think of. There is an amazing array of things you can do with Node-RED and just USB. You don't have to do. I just want to mention, I didn't get the opportunity to fit this in, but if you imagine how much more trouble it would be to do this over wireless using MQTT or some of the lovely protocols that are out there for doing Internet of Things. Sometimes it really is just easier to use USB and Node-RED, and it will just work. And it will work every time you turn it on, and you don't have any weird pairing. You don't have to... having somebody done a lot of stuff with Wi-Fi devices, it's a nightmare. It just goes wrong so easily, and debugging is problematic because you're running over a network. So the problem could be anywhere. Whereas this is so much more reliable and easy to set up, and cheaper as well. All these things are really cheap devices. Every Arduino comes with a USB port. I don't think I know of a single Arduino that doesn't have USB built in. Whereas only a handful of Arduinos, and very expensive ones at that, have Wi-Fi built in or have other ways of communicating. So also a lot cheaper. I've written a little tiny library for just receiving messages and storing settings on microcontrollers. I will be adding to these after the talk, because I've got this talk to give again in the future in October. So I will be improving this talk and also improving these example libraries. And this middle one is the thing for turning on those HID relays I mentioned earlier. I hope some of that sticks. I know it was a bit of a roller coaster. I apologize for any roughness. It's been a bit crazy the last few weeks, and I'll now go on to fun images, but thank you very much.
Q&A questions? You have time for a couple?
Yes, absolutely. I've got all the time for Q&A questions in the world.
I have a question. You show this USB to Ethernet converters or USB to Cat5, and this Fermata firmware, which you can load to Arduino. Can you do something with Ethernet Shield that you can put multiple Arduinos on the network, and they will be accessible from Node-RED?
I haven't seen. I did see. Oh yes,
because
someone had.
Then I can avoid this fragile USB, and I can use just Ethernet.
So yes, you can use an Ethernet shield. I don't know how well Fermata works with the Ethernet shield library. I would opt for the USB option because I find that I've used Ethernet shield for Arduinos and they failed me. They've reset on basically bad networking. So a bad switch will make it pull too much power and drop out. Kind of weird stuff going on with that. There's a lot of very badly made Ethernet shields.
I agree. I did some modification to Ethernet shield that I have my own reset. Otherwise it was frozen, and even the library wasn't good. So with some watchdog I need to handle that it restart when stop communication.
The best Ethernet shield I've used at the moment, and it's still quite hard to find, it's not even a shield, is the WS5500. There's an earlier model, but WizNet. It's the WizNet.
550.
yeah,
it's the
zero,
second
zero.
version.
Because the earlier one still a little bit iffy. The new one is a little bit more robust and slightly cheaper, I think. Oh God. Yes, this. Right. So I'll just tell you when to close your eyes.
That answers a question before you flip.
Yes.
How do the Arduinos cope with a keyboard matrix?
Like this kind of keypad matrix.
Yes, because you've got X and Y strobes and rows and columns.
Yes, that's right. In fact, actually, you might notice that one of these is and one of these isn't. So this one isn't a matrix. This one is, where it's got rows and columns. It loves it. There's a built-in, there's a very easy access library just called Keypad, and you just tell it which pins are which, and boom, it just works. So yeah, that's pretty good.
Okay.
Doesn't have any problems. And in fact, I think the Arduino Nano, which is I've picked up from China for £4, has got just enough number of digital pins for a large 4x4 like that one. Right. Oh God. So here is what my workshop looked like while making this. So yeah, I just wanted to talk about the Payphone and just point out that this. I had to make my own keypad because I got a 1990s Payphone here that I had to put in the escape room. Because one of the ways you communicate with the operator and do some other things, which I can't talk about, is with this Payphone. So this was I've recreated the features of a Payphone. So you can lift up, you can dial numbers, it has the tones, it makes all the kind of appropriate noises. It's even got the little display. Do you remember the little LCD display on the Payphone where it tells you the number you're dialing? When you lift up the handset, it says dial number. Yeah. I had to build all that from scratch. It took me 2 days, which is the advantage of Arduinos, I guess. I tried not to put too much brains once again in this, so really all of the Arduino really handled was the display and the keypad. When you typed in a number, it sends it to Node Red. Node Red works out what to do. So when it connects you to the operator, it's working out, the PC is working out that you've actually typed the right number. So that is my own matrix that I had to build to fit the Payphone. Oh God, let's see, spies. Yeah, there's the finished Payphone. It's an absolute monster. I think what was really upsetting about it was we were quite close to finishing, and like, so you're all like, oh, what secrets can we see? Just want to point out 3D printing is the best thing ever when you're. So I was given the task of making a release mechanism, and something had to just be gently pushed. And I built this in a day. So this 3D model was printed using OpenSCAD, and very quickly, it was based on another one from the internet on Thingiverse, but actually was completely the wrong size and shape for my servo motor, and didn't have some other bits, so I just made some adjustments. But my God, like the thought of having to make this from scratch was just, gives you chills, because I didn't have any time to do this. This was a very last minute addition. I had no time to really add to it. Let's see. Right. Oh God, no, don't look at anything. Everyone close your eyes. No. So I borrowed my friend's Prusa. So I've got a. I think you might have seen a picture earlier on. I've got a really cheap Chinese FL Sun, and it's beautiful. It's a Delta printer. But we had to make some really big things. So this is a very small part of a much bigger thing, and so we had multiple Prusas running round the clock to try and print all the pieces. And if you need a 3D printer that doesn't need to be constantly monitored and will recognise when it's run out of filament and it just generally doesn't go wrong very often, oh my God, Prusas are amazing. They're worth the £800 for them. They are absolute gold. I can thoroughly recommend. We were printing in PETG, which is a recyclable plastic. It's quite tough, but it's also quite. It's got quite a bit of flex in it. So if not that you'd notice when you print it solid, but overall it's actually a really nice. It's not brittle like PLA. It's not toxic like ABS. It's a really nice filament type. I wanted to find some of the damage. I'm not going to be able to find it. No. Okay, never mind. I won't ramble on anymore. Yes. There's a creepy Victorian doll. I won't tell you what it does. It's a thing. It's really creepy. Maybe you can guess. There's some clues. But yes, that's the wonder. Any other questions? Any more for any more?
What is the bus factor of this escape game?
What's the what?
Bus factor.
But
How many people need to be run by bus to maintain the software for the escape room?
oh, interesting. Okay, so obviously, I am the only person who has worked on the code. However, I have thoroughly documented everything, and I think it is simple enough that if I was run over by a bus tomorrow, anyone could pick it up. With anyone with like a decent bit of software experience would be able to understand. I don't think it would take any time at all for someone to pick up. So I don't know what the answer is to that. Like, is it below 0? Is it above 0? If
It's 1.
is it 1?
It's one.
But like, yes, if I'm run over by a bus, it is like, oh God, what are you going to do? But I think you'd be able to find a replacement for me, and it wouldn't be the end of the world.
Not really your problem, either.
Yeah. Yeah, it's not my problem anymore, but I still also feel a great deal of responsibility to my client, and I see their face whenever I talk about, crossing the road.
I found something similar in my case quite complicated when something goes wrong and I'm somewhere else and stuff stop working. That it's quite hard to fix it when it's something not standardized or.
Yes. I want to make this a standard, and that's why I'm giving a talk at an escape room conference in October, and basically I'm going to be pushing Node-RED as the industry standard control system for escape rooms, because there are companies that charge a great deal of money for bespoke escape room software, and it seems unnecessary in my opinion. I think most of what escape rooms can do, given their nature, can be done in this, and could be used without all the kind of fancy software that's extremely expensive being made, that no one understands how it works, and it's all compiled. I've done a thing where I've asked my client to open up Node-RED and make some changes live, and they've done it, and they have no programming experience, and they don't seem terrified by it. So if I can phone up and problem solve on over the phone, and they can fix something, that's a pretty good sign to me that I made something that other people can understand. Thank you.
Right. Can we have a big round of applause?